Thank you all for coming. My name is John Harrington. I am one of the co-founders of HighByte. HighByte is a software company. Today we're going to talk about Industrial DataOps. A little bit about me and about HighByte. So HighByte's mission or focus is to provide data infrastructure to manufacturing and industrial companies who are going through industrial transformation, Industry 4.0, call it what you will, but who are trying to drive business faster, more effectively, and more efficiently by leveraging technology. HighByte is a young company. We were formed in August of 2018, but the team has worked together for many, many years. The three co-founders of HighByte all previously worked together for many years at a company called Kepware Technologies. That gave us a real deep understanding of industrial automation, industrial data, and some of the challenges there. We also spent a couple of years together at PTC after Kepware was acquired by them. So deep understanding of IoT. And then as we left, we all left PTC, and then shortly later got back together and decided to found HighByte. We are based in Portland, Maine, so it's a beautiful sunny day outside at about 45 degrees. So that's Fahrenheit. So a little chilly, but certainly a warm up from what it's been the last couple of weeks. So again, thank you all for joining. I wanted to start off with this survey results that recently came across my desk. They were presented by CFE Media, and it really gets to the heart of data ops and industrial data ops. And they had surveyed their engineering base. So CFE Media produces Control Engineering Magazine, Plant Engineering Magazine, Oil and Gas Engineering. They've got lots of websites and additional magazines and periodicals. So very much in our industry. And they asked people, what is the biggest struggle with the IT/OT collaboration? And it just really struck me that 47% of the respondents said normalizing and contextualizing data. And that really gets to the heart of data ops. And another 28% were achieving connectivity. So that would have been over 75%. So these are some of the key topics that we're going to talk about today. So I thought this was very relevant. This was data that was recently presented to us in January. So really relevant, really interesting. And they had this was a survey with over 200 respondents. So definitely a broad swath of people. So what is data ops or industrial data ops? So IBM, who's been around for quite a while. IBM defines data ops, and they've been in this data ops business. They were one of the early people talking about it, and they define data ops as the orchestration of people, processes, technology to deliver trusted, business-ready data to data citizens, operations, applications, and AI fast. So I think that's a great definition because it really pulls together. It's not just about the technology, it's about the technology, the processes, the people. They refer to it as an orchestration. I often refer to it as a responsibility or a discipline within an organization, within a corporation. So IBM, Hitachi, and there are many other companies that have really been talking about this concept of data ops. Many people say data ops fell out of or came out of the DevOps movement, but they say it's DevOps for data. So they call it data ops. So it's adding that discipline that DevOps did on the software development side into the data side, into the data management side. We often also refer to it as the curation or preparation and delivery of data for analytics and visualization. So wherever it needs to be stored, visualized, analyzed, it's delivering it to that. It's the movement of the data, not the actual analytics or visualization. So we talk about industrial data ops because we believe, and I think many of the people on this call would believe, and understand that when it comes to industrial data, it's different than IT data. Integrating your factory floor with your IT systems and moving data, say, up to the cloud is very different than if you're integrating your marketing system with your ERP system. So there are lots of challenges that you have in the IT space where you've got various transaction systems that you need to integrate. But what I'm going to talk about today and what we're focused on is industrial data ops, which really starts in the OT side of the business, and it starts at the edge with the devices and machinery. So when we look at the concept of processes, people, and technology, on the process side, data ops is about defining data contracts and data governance between systems. So what information is being passed and how do we confirm and make sure that it's being passed cleanly? It's defining semantic data definitions so that you can define your data and structure it the way that it needs to be structured so that it can be easily utilized. Okay. On the people side, on the process side, it's about creating that architecture, right? The architecture of how the systems are going to be integrated. And on the people side, one of the key changes that we've seen on the OT teams is that they generally have not had architects in the job title of the people on their team. And we're seeing that more and more now. So for many years, the IT teams have had information architects or system architects, data engineers. Now we're seeing that on the OT side, or at least those IT folks are working with the OT side so that they can better architect the solutions. So on the people side, we're seeing you have your traditional OT team of controls engineers, automation engineers, of SCADA engineers, of sometimes chemical, electrical, mechanical engineers, but it's taking that team and augmenting it with more architects, because as you'll see, the data delivery is much more complex in this new world of Industry 4.0. And then on the technology side, it's really starting at the edge, because that's where the machinery is, that's where the data is often created, and that's where a lot of the challenges are. It's utilizing new architectures like data hubs. Instead of layering the data up, utilizing data hubs to move data through systems very quickly and efficiently. It's utilizing concepts like a unified namespace and data models to structure your data and to make it easily available and accessible, and then leveraging open standards to move it. So let me get into why this is needed. Like, what's changed and why do we need this new focus on data ops or industrial data ops within your factories and within your businesses? As we look at the manufacturing technology landscape and you look at Industry 3.0, we often refer to the data flows in what's in this stack of systems. And I've put SCADA and MES staggered side by side. Some people, in many cases in the Purdue model, technically they're on top of each other. But the idea is that data flows up the stack. It starts at the I/O, it moved to the machine controllers or PLCs, it moved through some sort of OPC server or connectivity solutions, drivers, and then it would go up. And most companies would either primarily use a SCADA or an MES. Some would use both, but in many cases, one was the primary system and one was a secondary system. And there are also HMIs out here. And then once in a great while, we would see it connected up to the ERP system. But in general, the challenges of Industry 3.0 were how do we get data out of all these different proprietary machine controllers and PLCs and make it available to the SCADA or MES. And this is where OPC came in very strongly and provided a great service there. So that all the SCADA and MESs had to do was support OPC, they were able to get access to that data. When we transition to the Industry 4.0, we see a lot of new things happening. Number one, at the device level, there's a lot of data being created that never makes it into the machine controllers and PLCs. It is only needed, for instance, for predictive maintenance. So it doesn't need to go, it's not used for process control. It doesn't need to go through the PLC. All that would do is add extra cost, delays in project. It would add a lot more complexity. And so the feeling is, let's just move that data out. So things like smart sensors and edge gateways have started to be used in the factory on data. Maybe it's less critical data, but it's critical for activities like predictive maintenance and asset maintenance and traceability and that sort of thing. So there's more data down at the plant floor level. But one of the other big, or the other biggest change from Industry 3.0 to 4.0 is the applications getting data. And just the sheer volume of applications, we're hearing from companies that they want to move data to their CMMS, their quality management, their ERP systems. These systems have been upgraded. They used to be, they're legacy type systems, but they've been upgraded through the years, and they can now consume high volumes of data and would like to be more data driven. At the same time, we're hearing about technologies like IoT platforms, data lakes, analytics platforms. Companies have multiple IoT platforms, multiple cloud solutions. Vendors have their IoT platforms. And the challenge is, how do we push this data to all these different systems and make it accessible and integrate them cleanly? The first approach was to create all these point-to-point connections. And these obviously went in over time. They didn't all just happen at once. No one would create this chart all at once, but over time they established connections. And in fact, in many cases, the systems in the cloud, the IoT platforms or the data lakes wouldn't just connect to the device layer, they would also connect to the application layer. So they would be pulling data from lots of different sources and try to put them all together. So the challenge is, number one, establishing all these connections, and then number two, maintaining them. But there's another challenge, and this really gets to the heart, and I guess that last slide was really the heart of that, the graph where they said connectivity. This slide is about the heart of this contextualization and normalization challenges that all those people said that they've encountered. So industrial data coming out of PLCs, machine controllers, sensors, even smart sensors, tends to be very raw. In many cases, the data was put in place for process control, but yeah, we're trying to use it for other use cases. So, in the last chart, we showed how you could be using the data in your CMMS or your quality management or your ERP system. Well, those are using data for predictive maintenance or for quality or traceability reasons, not for process control. A lot of the raw data is there, but we often have to reconstruct it and reposition it in order to make it useful. At the same time, as you look across a factory, in many cases, each piece of machinery has its own data model and its own data structures and the way that it describes and references data. So we have this inconsistency of how the data is structured that we need to get over. And so if we just move it all up into, say, the cloud, then someone needs to go through there and standardize it, because we've generally had a lack of standards across the different machinery that we're working with in our factory. Even down to the units and units of measure definitely haven't been standardized at all. And in many cases, there's been no context put on the data. So a PLC or a machine controller operates in a factory. It doesn't move generally. It sits in one place in one work cell and it operates. So it never needed to know where it was. It didn't need to know what factory it was in. It didn't need to know what line it was on or even what work cell it was on. It would get commands from the MES system or the SCADA. It would run those commands or make those changes, and then it would report back information of what was going on. Well, that was great when the only target that it was sending data to was that MES or that SCADA system. But now that we're sending it, say, to the cloud, we're consolidating and looking across the entire line, or even the entire factory, or even worse, the entire company, or I shouldn't say worse, even more opportunity is to look across the entire company. Now we need to have context on the data, or else we don't know what it is. We need to know, number one, that value is a temperature. We need to know what machine it's off, what it's taking the temperature of. We need to know what line it's on, what factory it's in. That way we can effectively analyze it and utilize it when we put it in our data lake. So that's really what we mean when it comes to adding context. So when we look at these challenges and you look at the connectivity challenge and the data challenge, people are still rolling this out. And the way that they're getting around it is they're writing a lot of custom code at the ingest of each one of those applications. So they're taking that data and they're using Python, or they're using Java, or they're using C# or you name it. There's lots of programming languages out there, and they're transforming that. They're first ingesting it, then they're transforming it, and then they're ingesting it into the application. And that brings about multiple challenges. Number one, industrial data it's just the integrations are not scaling, because that's a lot of work. That's a lot of work when you had to do it in your SCADA system. But now if you're doing it in 5 different systems, it's even more, or 10 different systems, it's even more. Number two, it's a lot of work for the wrong people. It's generally the people that administrate these systems, these applications, are on the IT side. And they struggle to understand that industrial data. So when it was just going to the SCADA and MES, the people that administrated those systems were generally on the OT side, had an understanding of the factory floor. They worked together with the automation engineers, and they would work through all those data integrations. Now we're doing it multiple times, and we're doing it with a team that's completely separate from the team that runs the factory, that knows that data. So that makes it also time consuming and expensive. And what we're doing is, by writing all these different integrations, we're actually then, if something changes or needs to change on the factory floor, because by the way, these integrations are so that we can run the factory more efficiently. So then we decide to make a change on the floor. Well, that's going to break a lot of those integrations. And so the effect is that it actually pulls the agility out of the factory at the same time we're trying to add it to it. So it just is not a recipe for success, and it's something that we need to do a better job with. And this is where DataOps comes in. So HighByte has developed the HighBody Intelligence Hub to address DataOps in the factory, to address that contextualization, to address the standardization of data, to address the connectivity to systems. That's what the Intelligence Hub is all about. And how do we do this? Well, the Intelligence Hub takes a hub and spoke approach to data integrations. We can connect to all your different systems that are in your company that you need us to connect to. On the factory floor side, we would connect to your OPC system, so your OPC server, like KEP server. We could also connect to any PLCs that have OPC on board. We can connect to any sensors or PLCs that have MQTT and are able to publish data over MQTT. But we can also connect to your SCADA systems or your MES. We could do that over OPC or SQL or REST, and your ERP. So we make all these connections, but that's just the beginning. What's really unique about HighByte is that at the core of our solution is a modeling engine. Now, the modeling engine is where you're able to create models based on how you're planning on using the data. So if you're planning on doing predictive maintenance, you create an asset model. If you're planning on doing product traceability, you want to create a product model or quality. If you're planning on doing process analytics or OE, you create a process model. So you create these models, and then you replicate them as instances when you apply the data moving through the Intelligence Hub. And it's these models that become the method for standardizing, normalizing, and contextualizing your data. Now, we developed this for the OT team because we believe that it's a lot of the challenges when it comes to industrial data ops is on the device layer. The device layer, no one created these challenges on purpose. However, you need to buy equipment. Equipment comes already upfitted with machine controllers, PLCs, sensors. So you're getting that into your company, and you need to be able to deal with it. So the key is that the OT team has the ability, they understand that machinery, they have the ability to map the data into these models and then run it through and send it up to whatever target system they need to go to. Now, for designing for the OT team, we made sure that this can run on premise. It's critical that this is installed as close to the highest volume of data as possible, because what we often end up doing is we're collecting data much faster than we're pushing it out. And when we push it out, we're able to buffer the data if any connections go down. So you want to be close to and typically in the same network as your industrial, as your OT solutions in hardware. But then, so you may even run it at the edge. But the application is an application, it's web-based, and it's a codeless interface. In fact, let me show you what the application looks like. So here's the HighBody Intelligence Hub. And you can see our software is structured just like that last diagram. We have connections, we have models, and we have flows. So here I've got connections to all my different systems. I have connections to an OPC server. In fact, I can go in here, and in order to get data into here from the OPC server, all I need to do is browse. I can browse in, I can select a series of tags, and I can import them. So it's very easy to bring data in. Databases the same way. We may have a batch database or a lot database. Here, with databases, our inputs are queries. So here I've got a query. I can even verify what that results are. So it brings in all this different data from a database, and I can then work with that data when I come into, when I run it through my models. So as you can see, we can create lots of connections to all your different systems, including Azure and AWS, which we have unique connections leveraging the SDKs of Azure and AWS, so that we can even make that easier than using some of the open protocols. Once we establish the connections and we establish the all of our inputs, then we come into modeling, and we can create models of lots of different things. So I can even organize my models in terms of a structure like ISA 95, or I have my asset list here. Here's a thermostat model, for instance. Now, I've already created an instance from this thermostat model, but the thermostat, essentially what you do is or a model, you create a series of attributes and you define what those attributes are. Once you've done that, then you create an instance. So let's jump in and take a look at one of my instances. So this is an instance, and in this case, I mapped in a series of OPC tags and a series of SQL tags. In fact, the way that you do that, it's dragging and dropping. It's really that easy. You come in, you identify the data tags that you want to use, and you would just drag and drop them in. So very easy to put various information in the system. On the SQL side, see, we're able to combine data from multiple sources. So here I've got some SQL database as well. So let me come into my my device database, and this is thermostat number 3. And we can see here all of the data tags from my query are available for me to also drop in here. So instead of saying Tony's office, I can just drop that in with a query to the database. I can add any data if I want to, but the key is you can put data in here. You can also type in data on the left here. So maybe you don't have certain information and you just want to say, you can save it here in this default field. So we can pull in real-time values from various systems, or we can type in values directly. From here, we can jump into flows. And now, as you've seen, I've navigated across. I went from connections to models to flows. I've already got this flow created and it's running. So this is sending out data every 10 seconds to my MQTT broker, and I'll pop that up and you can see it coming in. Now this is MQTT Explorer. This isn't our solution. This is an open source solution, but it's a great way of looking at your MQTT data. It's a client connecting to my broker. And if I look under my buildings, you can see this is my thermostat that I was just showing. In fact, you can see all the data. So I've standardized the data across multiple assets by running them through the standard models. Now I've done this for filling lines for the lot data. Remember, I had that SQL query. I can pull all that data in and also build that up. And I can look at OEE, and I can look at what's going on in the lot, in the line during the time that the lot was being produced. I can also look at, presses or different assets. So you can create structure in how you store your data in your browser. And many of our customers are following the ISA 95 model for how they're building out their data. But then at the bottom of your structure is the payload, and that's what is the model instance that we're publishing. So hopefully that gave you a good feel for what we can do with data in the HighBody Intelligence Hub. Again, we make those connections, we bring it into the model, standardize it, we normalize it. I could have run lots of different expressions in my expression field to transform that data. Maybe you need to strip it away, maybe you need to run some calculations on it. And then you push it out with the flows. So now let me finish up the presentation. Just real brief, the HighBody Intelligence Hub, we've designed it for industrial data. We've designed it for scale. In fact, I would argue that one of the biggest challenges, there are a number of solutions that can solve some of the data ops challenges if you've got 10 data tags. There's custom programming that does it great. It's fast, it's easy. Lots of people know how to program. But the challenge is when you go from 10 data tags to 100,000 data tags or 1 million data tags and lots of different systems, that whole problem gets dramatically harder. And that's where HighByte comes into play. We are focused on the scale of your factories in your corporations. And we've designed this for OT, for the OT team, so that they can get access to the data that they need access to and own and maintain the systems that they need to. With that, I just want to say thank you to everyone. I don't know if there are any questions. I probably should have started off by asking if people had questions, but we are taking questions. Aaron's with me. He's been manning the Q&A, and we'll be able to take any questions that come up that he wants to answer live or that he wants me to answer. Before we do that, though, I guess I'd like to ask you one quick poll question. I'll launch my poll here. I'll give you 15 seconds to respond, and then we'll take a look at the results, and then we'll be ready for answering questions. And in the meantime, if anyone wants to hear more about HighByte, if anyone is interested in trying out the software, please feel free to go to our website or reach out to us, and we'd be happy to set up a call, have a discussion, and tell you more about it and see what your projects are. All right, let me end the polling, and I would say let me share the results with everyone. This is great news. It sounds like a lot of people are researching and gathering information, but some of you are starting projects or planning on starting projects, and we look forward to working with you on that, either in the 3 to 6 month or 6 to 12 month range. So at this point, Aaron, let's take some questions, and let me stop this share, and then are there any questions that people have posed to us?
I see someone's asking if SAP Connector Direct, or do I need to use Sepasoft? I think Sepasoft is a third-party tool. I'm not quite sure, but in terms of HighByte and SAP, today we have a REST connector, which is a fairly generic way to connect SAP, and that's really only their latest cloud changes. So from that, we're looking at building something potentially to connect to the BOPIs in SAP, so to expose that via REST API or something like that. So we don't quite have that today, but if you do have access to your SAP system through REST, that works today. And then midterm, we're looking for something a bit more native.
Yep, or SQL connections, not directly to the SAP tables, but we could use that as an intermediary.
Yep. Yeah, SAP is unfortunately kind of a tricky, a tricky beast. But
tricky beast.
Yep.
There's another question about the slide deck. We can certainly make that available to anyone that would like it. We are posting the video of this online. So if there are any other, if anyone wants to share it with others within their company, feel free, come to our YouTube site, and we'll be able to, and you'll be able to find it. We'll also be emailing you a link after this, after the webinar here. At this point, it is past. We had tried to keep this to a half hour. So I guess at this point, we'll wrap things up. And there is one more question. Will we see an established ISA pyramid?
SepaSoft is an MES system. So they have a connector apparently to SAP. So we do connect to a lot of MES systems through SQL interfaces. So that's another option to get the data out of SepaSoft from SAP is one option.
Yeah, so there's a question about the ISA 95 model, the pyramid model, the Purdue model, if you will, the layered model of moving data. And the question is, do we see it as more of a star model moving forward? Certainly, we believe that, you know, when I look at the SAP or the ISA 95 or the Purdue model, it does multiple things. It was initially designed as a way of defining what data goes at what level and in what systems, and aligning some frequency to it. I definitely see that there's a level of that is very relevant and will continue to be relevant moving forward. However, there's definitely there's some changes in some of that, because, for instance, analytics was typically at a high level and the frequency was very low, and the idea is that now people are starting to do much more higher resolution analytics. So some of those are breaking down. But people have also used that as a way of flowing data. And I think when I think about it, I think of it as almost another dimension to it, is that the data flow needs to not flow up through the stack. Because if SAP needs a certain data item that is only in a sensor, we don't need to push it through all those different layers and all those certified applications just to get it there. So I think of it as a different layer, as opposed to kind of blowing up the pyramid. I think the pyramid has some value, but data flow needs to be separate from that. And I do think that data flow needs to be more of a star environment. The reason being that in many cases, the data item that's in that sensor needs to be combined with maybe some information in the MES system. And it's those two pieces together that then is very valuable when it reaches the data lake. So what we see is it's much more of a combining data, it's pulling it all together and aggregating it. So it's definitely not a layered approach to data movement. Otherwise, you end up overloading your SCADA system, your PLCs, with data that they never even need to see or use, because it's not part of the process control piece. Okay, well, at this point, we're gonna wrap things up. If you have more questions, feel free to reach out to us. We really appreciate everyone getting online, and have a nice day. Thank you.